So product means it is an assembly window. I told right, sketcher, part design, wireframe, assembly. So product means it is assembly window. So by default, this assembly window will open. So you should close that. Okay. By default, assembly window, product window will open. You can close that. So now we are going to see the sketcher window, right? So for that, you have to go to the start, mechanical design. So in that, n number of sub modules are there. So we are going to see only 5 modules, sub modules. So sketcher, part, wireframe and surface design, assembly, and drafting. Only these 5 you are going to see. Okay, now you will go to the sketcher. Okay. So after closing, you have to go to the start, mechanical design, sketcher. Simply select OK. Actually, this is the part window only, but this is the sketcher tool. So all other tools are in normal color, but it is highlighted in the orange color. Okay, this is a sketcher tool. So you have selected the sketcher. So this tool is selected. So if you don't know what is the next step you want to do, you can read this bottom line, the left corner, lowest corner. Select a plane or planar face or a sketch. Okay. So sketch tool is selected. Now we have to select on which plane you want to draw, whether it is XY plane, YZ plane, ZX plane. Here or here, anywhere you can select. Okay. So I am selecting this YZ plane. Now this is the uh, sketcher window. I'll tell you the important toolbars. So this is the view toolbar. Then second I told profile toolbar. Actually you can drag anywhere. Okay. And if you want to, do you hear me? Am I audible?
Yes, sir.
Yes,
Here.
sir. Okay, okay. And if you want to change the orientation from horizontal, vertical to horizontal, simply you have to select shift. Okay. If you select the shift, the orientation will vary, will change. Now also it is vertical. I'm pressing the shift, so it is changed, constraint, and this is finally workbench. Okay, so view toolbar, profile, operation, constraint, workbench. Additionally, we have sketch tool,
Sir, your voice is coming too low.
tool over. Okay, what happened? While pressing shift control and all, I have to use both hands. In that time, my headphone is falling, so this happens. Now is it fine?
Yes, sir. Yes, sir.
Okay. So first tool is view toolbar. You know that. So it is fit all in, pan, rotate. This is basic. Almost in all paint software, you can get this type of toolbar. So it is easy. So second one is profile. Using this, you can create the continuous lines. For example, you see, I can draw the straight line. Okay, if it is inclined, it will be in white color. If it is straight horizontal or straight vertical, it will be in blue color. Okay, so I can draw the horizontal line, inclined line. Then now you see sketch tools. Previously, only these 5 tools are there. Now it is expanded. So here you can select whether if you want to draw the arc. So like that, continuously you can draw the lines. And if you want to terminate, the same tool you have to press. Otherwise, you can press the escape button so that you can terminate. The next one is rectangle. If you expand, you can get a number of rectangles. So oriented rectangle, parallelogram, elongated hole, keyhole. So keyhole, elongated, lot of things are there. Then circle and different types of circles: 3-point circle, coordinate circle, tangent circle. Then different arcs. Then spline. Spline means like so some smooth profile like aerofoil profile and all you can create it. And the main important thing while drawing the profile is, so always software creates some auto constraint. You can see I'm keeping the point here. There is nothing extra lines coming, but now you can see one horizontal blue color line, and that line shows coincidence with this rectangular horizontal line. You can see now. See, okay. So there is a auto constraint. Now if I select Now if I terminate by selecting this, you can see this O symbol. That means this point and this line, there is a auto constraint, okay, coincident constraint. So what will happen due to that? You see, I can move this point. I can move this point because it is not at all constrained anywhere. But this point I can't move. Actually, now I could move because it is not fixed. Once it is fixed, now you see vertically it won't move. This way it may move, vertically it won't move. Like that, sometimes there will be auto constraint. So when you design the profile, you should be careful. There should not be any auto constraint. Okay, if you want to delete, simply you have to select that icon and simply press the delete button. Even if you want to delete this line, simply select and press the delete. Okay, it will be deleted. Okay, then ellipse, if you expand, you will get hyperbola, parabola, those things. Then line, then axis line. Axis line is just for our reference. Okay, so software will not consider these lines. For example, if I exit this sketcher and go to the part design, you see that axis line is not there. Okay, so it is just for the reference. But this point, you should be careful. You should not create it unnecessarily. Actually, to create the 3D, for example, if I don't want these lines, simply I am doing the box selection and deleting it. Okay, and delete it. So if you want to create the 3D model, then the profile should be a single closed curve. So this rectangle, I can convert this into a rectangular box. But if I create the box like this, if I create the box like this, I cannot go for the 3D because there is a opening. Sometime this distance may not be visible. If you normally see, it will be like closed. Okay, but if you try that, after will tell it is not the closed profile, it is a open profile. Like that, it will show the error. You can see now. You see, it is completely closed. So all the points are in white color. But this profile, you see, it is closed. These 3 points, so it is in white color. It is not closed, so it is in black color. So these open profiles cannot be used for the 3D design. And also, so only one profile should be there. If you take two profiles like this which are intersecting and you try to do the 3D, it won't work. Okay, so 3D works in the different way. So if I give one 3D model, so each projection, each component separately you have to create it. Okay, so this is about profile tool, how to create it. Then operation toolbar. So using this corner, you can convert. That is, you can select these two line, or if you want, you can select the corner also. You can convert sharp edge into the rounded edge, or you can convert sharp edge into the flat one using chamfer. Sorry. And if you expand the third one, relimitation, you can expand the fourth one, transformation. You can expand the fifth one, 3D geometry. So a number of options are there. So this is like trim, this is break, this is quick trim. So if you want to break the line, this line, if you want to break it with reference to this axis, now you see it is two lines, separated as a two lines. Okay, about this axis, it got separated. Or trim, there is quick trim. Mostly we will use this quick trim. That is unwanted line, you can delete it. For example, mistakenly you have drawn another one profile like this. Okay, so you don't want these extra projections. So simply select, it will be deleted. So up to the intersection point, it will be deleted. For example, here, if I select this, it will be deleted between these two intersection point. Like that, you can delete the unwanted lines. So mostly with this quick trim, we will use it. Okay. Then transformation. If you have one profile, you can do the mirror. That is mirror image we can create, or we can do symmetry. We can translate, rotate. We can increase the scale. we can offset, all those things we can do it. Okay, offset means, for example, this is the profile. So this is the profile. So if you offset, you can see the same profile. We can reduce the size or increase the size. And again, this sketch tool is expanded. Here you can give the value offset design, whether you want to offset it outside or inside, that you have to decide. For example, if then this blue color line it is showing, right? So it should be inside. You should not keep it outside. Okay, it should be inside. In that case, you can move it a little bit this one. You move this, the blue color line is inside. Now I can define as 20. So for 20 distance, it is offsetted. Like that, you can use these tools and all. Then constraint. So this is to give the dimensions. For example, so this line I am selecting. So I am getting 397.482 mm. Assume it should be 400 mm. Okay, we can change it. Okay, then this vertical line I am giving, it is 239. So just double click to change it. Give it as 300. Either you can change it. Okay, this is how you have to give the dimensions. Another one thing. Okay, these things I will close it. Okay, so I am going to give the dimension for this rectangle. So we know for rectangle, these are all the two major dimensions, length and width or height, anything you take. I'm taking this as 400, this is 300 or 200 something. I'm taking on rectangle. So this is the required dimension, right? For rectangle, only two dimensions are required. Actually, after it is constrained, this white color line will be turned into green color. With that fully constrained green color line profile only, you have to take it to the 3D design. Okay, because anytime you can reedit the design. For example, there are 10 20 steps. Okay, n number of profiles you created for the single component. At last you are coming to this first profile. You see it is movable anywhere. So mistakenly you selected and it is moved, and you can update it every time. It will be automatically updated. Now if you exit and go to the final component, because of this movement, totally there may be a distortion happen in the final design. So always when you create the profile, we have to constrain it properly so that it should not move anywhere. So how to do the constraint means, dimensions we have given, then we have to arrest the degree of freedom. Okay, it should not move vertically, horizontally. So those arresting, we can do it with respect to these axis lines. Okay, so you can fix the rectangle like this in the center, or at least at some certain distance, or even at the center, like that. Depends upon the geometry, you can fix it. For example, I am going to fix this rectangle as a symmetry with respect to this axis. I have to use both hands. So if you are facing any audio issue, you please let me know. Okay, so it should be in the center. That is, it should be symmetry about this axis. So in simple way, if you want to use the symmetry means, what you can do, you can select this constraint. You can select the line and the axis. I am getting additional dimension. This I can give 100. Now see, it is constrained. Similarly, here also I can give the distance. So it should be 200. Now see, it is completely constrained, green color. And if you try to move also, it is not moving anywhere. Like that, you have to constrain the profile. Then only you should go for the 3D design. But here it is 200, so I have easily given 100. But if the number is large and complex, that time it is difficult to find what is the half value. So in that case, you can go for the another constraint method. For example, this is symmetry, right? That is, these two lines are symmetry about this axis. Okay, so these two lines first, then the reference axis. Both I have selected. And if you want to continuously select, you have to press the control. Otherwise, if you select one time and next time if you select this, it will be gone. So continuously, if you want to select, press the control, then you can select. Okay, two outer edges and the reference axis. Now you can see first tool is opened, enabled. So constraint defined in dialog box that you open, you are getting a lot of options: symmetry, tangency, coincide, parallelism, perpendicular, etc. and all. So here we need this symmetry. Select. Now this is the symmetry symbol. Now see these two lines are green. Same way I can give symmetry for these two lines with respect to this reference line. Now this is enabled. I can give symmetry. Okay. So like that you have to constrain. For example, you are drawing another one circle here. We know for circle only the radius is the only dimension. Give it is 500 and it is moving here and there. Now we have to arrest the movement. Assume the circle line is tangent to this vertical line. So we can give the tangency. For example, select this line, select this circle. Now first one is enabled. You can give tangency. Okay. Now these two lines, two parallel line is there. That shows the tangency. Still it is in white color. That is because this center point is not fixed. Okay. So how can we fix that? Is horizontally it won't move, only vertically it is moving. So what I can do? Any idea how to fix this?
Sir, that parallel to that axis,
Yeah.
that center line.
Yeah, good. So we can make this line parallel to this. That is coincidence. Okay. I am selecting the center point and this axis. So first one is enabled. I can give coincidence. Okay. So this point coincides with this axis. Now it is in green color. But still we can't use this profile for the 3D profile because there is intersection. Okay. At a time, we should take only one profile. That would be better. Okay. Yeah, now I am going to explain the important toolbars of the part design. So actually here none of the toolbars are visible. So sometimes it will happen. The toolbars may be missing. In that case, we have to right click on any of these sidebars. This bar sidebar, anywhere you can click. Okay, here or here, anywhere you can click and press this down arrow. You can see this customize option. Then toolbars, restore all content. Okay, restore position. So with that we can restore all the toolbars. Now the important toolbars are, first one is sketch based feature. Then second one is dress up feature. The third one is transformation feature. Then reference element. Then the sketch. So these 5 are the important toolbars. Okay, so now we will first see these sketch based features tools. So first one is pad. Okay, so to use these tools, first we need some 2D sketch. So to create that, I am using this sketch tool. Then we have to select the reference plane. For example, I am drawing one circle. Okay, I am taking the center point, drawing circle. You know, you should give the proper dimension. You should turn this into green color before going to the workbench. So one circle I have drawn. Now if you use this pad tool, I can convert that circle into a cylinder of 1000 mm length. Okay, the solid cylinder I can create it. And we have additional options. So you can give thick. Okay, thick means instead of the solid, it will be like a tubular structure. For example, thick if I given, it is asking the second limit or this thickness and all. So here you can define the thickness. I am giving 2 mm thick. You can preview. Now you see, now it has become 2 mm. Either both side also you can increase, outside also thickness you can give. So this is thickness. Then mirror extend. Mirror extend means opposite also it will be extended. Okay. And sometime you can use the dimensions here. Even you can use, for example, some other components are there means you can use up to last, up to plane. Either also you can give. Okay. So using pad you can create solids. It can be a complete solid or it like a tubeless structures. Anything you can create. This is the first tool. Here also you can do controller set like a admin software. Now we will see if we expand this part design. So this is normal pad. This is drafted filleted pad. This is multi pad. Okay. So this multi pad I will explain now. For example, if you want to re-edit this sketch, select the sketch and select this sketch tool. Okay, it will go to the same sketch. Or sometime, if you want to re-edit it, simply you can double click. This will also work. Okay, now I am drawing another profile here. Okay, in rectangle. So you should view all the further dimensions. So here 300, here 300, and we can make it a symmetry. Okay, now it is completely constrained. Now go to the pad part design. Now see if I use this pad design, what type of 3D image I am getting. Select the image because both lines are in the same sketch. So actually in the tree you can see all the steps you have done. Okay, it is like a history. So there is only one sketch. Okay, there you have two profiles. So select that sketch. Give say 1000 and preview. You see we got the material filled between these two profiles. Okay, here also you can give thickness. It will be like this. Okay, like tubular structure. Mirror extend, it will extend on both sides. Okay, so if you use the normal pad option with the two profile, you will get the material filled between the two profile. Now assume okay, I will show how to use this multi-pad. Okay, this is a multi-pad. Now select the profile. Now we have the option where we can give separate the projection length for two profiles. For example, this is the first profile. I want to project this for 500 mm. Okay, see this rectangular is projected to 500 mm. Then second profile 1000 mm. Now if you view, you can see. So rectangle is up to 500 is projected, but the cylinder is projected up to 1000 mm. Like this type of image design you can create it. Okay. So next one is the last tool and the pad toolbar, drafted filleted pad. So first one is simply pad, but here we can do draft and fillet. So let me explain how to use this drafted filleted pad. Okay, I will modify this profile. I'm taking only rectangle. First use the normal pad. Just I need some base for that. Okay, I have base. So on this face, I want to create another one profile. For example, I am drawing another one square and give the k dimensions. Okay, 120. This is also 120. Then symmetry. So my profile is ready. Go to the part design. Now you know how pad will look. If you simply select this, it will be projected to the 100 mm. For example, here it is 100 mm it will be projected. Now we will see how to use the drafted filleted pad. Okay, select the tool and select the sketch. Now we are getting this type of window. So along with the length, it is asking second limit. Okay, for the second limit you can choose any plane or surface. For example, I want to choose this surface as the second limit. Okay, so limit got selected. See, in addition to the pad option, there is option for draft and fillet. Okay, so now the default value they given is 5 degree. Now you give preview, you can see the edges are inclined to 5 degree. If it is not clear, you can further increase also. For example, I am giving 20 degree. You can see the edges and the side faces are inclined to the 20 degree now. And if you don't want to use this option, if you unselect it, it will be like a normal pad. Okay. Okay, so first one is draft, where you can define the draft angle 5 or 20. For example, I have given 20 here, so I am getting this type of profile. Then come to the fillet. So in the fillet, fillet means converting the sharp corner into a rounded one. So already the default value is 5 they have defined, and 3 radius are mentioned: lateral, first, second. So second, I have chosen this as the surface. So this is a second limit radius. Let's see how it changes. I am giving 20 for this radius. Just click anywhere so that this preview will be enabled. Now see, from 5 it is changed to 20. And then see first limit radius, it is again, so this is second, in the opposite side should be the first. Okay, so this 4 corners should be the first limit. That also I am changing from 5 to, for example, 30. Look outside, so this preview will be enabled. Now you see from 5 to 30 it changed. Then the last one is lateral. Lateral means, so these 4 corners. Okay, so these 4 corners, the edges, that also you will see. Instead of I am giving 50, click outside. Also there is also changing. If you want further, you can increase, for example, 40. Okay, so like that, using the second option, we can pad the profile with fillet and draft. Okay. So next one is pocket. Okay, first one is pad. So pad is to create the material. Next one is pocket. Pocket is to remove the material. Okay, so just opposite. And here also, if you expand, you can see pocket, drafted, filleted pocket, multi-pocket. Almost same way it works in the pad tools, but instead of creating the material, it removes the material. Let's see, we can use the same rectangular profile. So we have a rectangular profile. So select this pocket tool, select the profile. It is asking, so what is the depth to remove the material? For example, I am giving 20 mm. So for 20 mm, it reduces the material. Or you can give up to last. It will completely remove the material. Okay. If you know 100, you can directly give it dimension itself. Or you can use up to last. Or if some other plane is there, for example, a plane also in the end, if it is in the middle, if you want to create the hole from this face to the middle, you can select 50 or up to the plane, like that you can give it. So the pocket is just to remove the material. So here also thick option is there. So thickness I am giving just 10. You can see like a slot, it removes the material. Okay, if it is normal pocket, completely within this circular square profile, the material is removed. But if you select this thickness from that profile, 10 mm only it removes. Okay, if you give 20 mm, then from these 4 lines inward 20 mm it will be removed. Like that it is removing. Okay, so depth is defined here, and this thickness is defined here. Okay, and mirror extent both sides will remove, but here it won't be applicable because opposite there is no material, so mirror restraint is not applicable. Okay, so this is how the pocket is working. So first one is pocket 2. Now you will go to this drafted filleted pocket. So I'm selecting the profile. Here also same, it is asking me the second limit. For example, I'm taking this surface as the second limit. If we give preview, okay, it is taking 100. That means close the thing it removed. Okay, I can reduce it to 50. So I remove it to 50, up to 50. So there is a draft angle 5 degree. If you want, you can change that to 20 degree. Press outside, then review. So in preview you can see from this profile 5 degree it is drafted outside. Okay, so it is similar to the drafted filleted pad. Okay, but here inward direction removes the material, that's it. And here also lateral first and second limit. We'll start with the second limit, that is the first surface. I'm giving 20. You can see this curved edges in the outside. Then first limit, this bottom surface, where I'm giving 40. You can see there also material removed for 40. Then this lateral, these 4 edges, okay, the side corners, where I'm giving, for example, 30. Okay, so like that I can create the profile. The view you can change it. So this one is just shading. This is shading with edges. This is with edges without smooth edges. Like that, n number of options are there. Anything you can set it to view. See, shading with edges. You can see all those edges how it is created. Okay. Then the last tool, multi-pocket. Okay. So this is also same way as multi-pad. So we needed 2 profiles. I have only 1 profile. So if you want to reedit this sketch, double click on the sketch. So there I can create another one profile. For example, circle I can take. Defining the radius is 200. Okay, now I have 2 profiles. You know, with these 2 profiles, if you use this normal pocket, it will remove the material between those 2 profiles. Okay, so if you use 2 profiles and use the normal pocket, it will remove the material between these 2 profiles. Instead, if you use this multi-pocket, so for both profiles separately we can remove. For example, first profile, see, after selecting this, it turns into blue color. So this rectangular profile, assume I want to remove the material up to 70 mm. Okay, on preview. Then this circular profile, I want to remove to up to 50 mm. So like this, we can remove the material for the multiple profile. So the next tool, shaft and groove. Okay, so shaft is like the pad. How pad creates the material, shaft also creates the material, but shaft creates the material with respect to axis. Similarly, groove, this is to remove the material similar to the pocket, but this groove also removes the material with respect to axis. So I have created one axis symmetric profile here. Okay, let's go to the sketcher. So normally I told you it should be the closed profile. Okay, if you want to go to the 3D model, it should be a closed profile. But this shaft and groove, it is exceptional. With the open profile itself, it can work. So now this is the complete profile. So I am going to rotate this profile about this vertical axis so that I can get like a jar-like structure. Okay. So without this line with the open profile also it will work. So let me show you. But it is better to close it. Okay. But I just wanted to show you without that also it will work. So I am trying this profile. So select the shaft, select this profile, then it is asking about which axis you want to rotate. For me, this axis, vertical axis, or in the tree if you see it is the Z axis. Okay, so here you can pick, or if it is not, I couldn't pick means here you can select the vertical axis. Okay, so it is, even though it shows the warning, it is an open profile, it will be created. Okay, that so only with this shaft and shaft we can create the 3D model with the open profile also, but it is better to be create the closed profile. Okay, so I have created the jar. You know, here also, so the shaft option also there is a thick option where you can define the thickness. So if you preview, you can see the thickness, but you can see where sir I couldn't see the thickness. Actually it will create like it is completely closed box, right? So from every profile it created the material up to 10 mm, so that if you want to see, so here you can check, you can see those lines are showing the edges of the solid model. So inside it is hollow, outside it is created. This is the one way of seeing. Or if you want to see another way is, go to the sketch, delete this profile, so that it is not closed, now it is open. Now if you exit, you can see, okay, it is the like a normal jar with a thickness of 10 mm. Previously there is another one line, so it is like a completely closed, but inside it is hollow only, it is like a shell only. I have removed it. Now we can see the thickness. Okay, the thickness of it you can see. So this is one option. Then second one is groove. Groove means you can remove the material. So better. So close the profile and take this thick, so that I'm creating this solid profile. Okay, so using the shaft, assume I have created this solid profile. Now I want to remove the material about the axis, outside, inside, anywhere you can remove. So okay, first we need the profile, so you can take any plane, go to the sketcher. Now you can draw the profile. For example, okay, you want to remove the material like this inside. So like this you want to remove the material inside. Now exit, I have the profile, use the groove. So this is my profile. The vertical axis I want to remove. Got removed. So it is not visible, means this line should be coincide with this line, then that slot will be visible. Coincide. I can see the material is removed for that profile. Even outside also you can remove, for example, draw this, draw some profile, for example rectangular profile here. So for this you want to remove the material, try include about this axis, material is removed. So like that you can create it. The same shaft using some other profile, simple profile. Instead of jar, you can take any plane. I'm just taking this for rectangular profile. You know, if you rotate this rectangular profile about this axis, it will be like a cylinder, a cylindrical profile. So use shaft, then about this axis or line I want to rotate, and it will be like a cylinder. Now assume we want to remove the material from this cylinder. So go to the plane, okay, so any vertical plane you can take it. So take the plane, assume for this profile I want to remove the material above the axis, so you can use this tool. So select the profile, then select the axis, so the material is removed. Okay, so this is how the glue works. And the glue also, we have the thickness option that if you give. Okay, so with respect to the profile, for 10 mm it removed. Okay, you cannot see this inside cut. Actually, there is a curved cut for 10 mm inside. Okay, like that we can see the thickness. If you don't define the thickness, completely it will be removed. That's it. So the next tool is rib and slot. So rib is to create the material, slot is to remove the material. So I will explain what is the difference between pad and rib. For example, pad just now shown. If you have a circle, you can project that into a straight cylindrical structure. For example, let's take one circle. So I have drawn one circle. So if you use the pad, we can project it into the straight cylindrical rod. Okay, but if you want to create a cylinder with a bent, then it is not possible with the pod design. Okay, it can be only a straight rod. If you want to create a rod with a bend, then that is not possible with this pad design. So for that purpose, we are going for this rib section. Okay, this rib tool. So for example, this is the profile, and so the bend profile I am drawing in the perpendicular plane. Okay. So the plane which is perpendicular to the profile I am taking. So there I am drawing the profile to create the bend. Okay, so for that I am using this plane to create the bend, and you can use any other tool also. For example, straight, then arc, another one straight. Just like that also you can try it. So always we have to create a fully constrained picture. So I have given these dimensions. Okay, so this is the bend profile. So now I have cross-sectional profile, also this top view profile, bend profile. Now you can use this rib tool. So this is the profile, cross-sectional profile, and this is the center curve. So for that, it has created the cylindrical rod which is bent. Okay. Here also we have the thick profile, thick option, where you can define the thickness. Then it will be like a tube with a bend. So like that, this rib tool is used. Then this slot also same way. So how pocket will work? If I draw one circle, and it will remove the material just in this straight axis. Okay, but if you use this slot, again you can define that bend profile, center profile, you can define it. Okay, so for example, I am taking this face. Assume I want to create a rectangular coordinate The cylindrical with thick profile itself, you can use it. Okay, cylindrical tube if you want to create. Assume I want to create a rectangular slot within this tube. So I'm drawing a rectangle, okay, square or rectangle. Then I need the profile, this pin profile. So if you remember those geometries, you can draw it again that profile. Otherwise, already we have that. So say, as I mentioned earlier, in this tree you can get all the history, what are the steps you have done. So this 19 is the profile I have drawn. So simply copy this and exit. Now on this perpendicular plane I want to create it, go to the sketch, because I copied from the sketcher only. So again we have to go to the sketch and paste it. Now the profile is pasted here. Again you want to constrain it. Okay, so now I have the rectangular cross-sectional profile and this center curve to define the bend. So I want to remove the material. So in that case you can give this slot. Okay, if you want to create the material, you have to use rib. To remove the material, you have to use slot. So this is the profile, this is the center curve, the view. So now the material is removed. Okay, cylindrical tube with a square duct. Here also if you provide thick, then it will be like this. Okay, for that profile on both sides, 10 out the material will be removed. Okay, if you don't enable it, it will be like a normal tube like structure. Next one is solid combine. So if you expand this solid combine, you will get two tools, stiffener and solid combine. So stiffener, you know that. So to support the member, we are using this stiffener. So first we need some structure to enable this stiffener. Okay, so I will draw the base component. Any plane you can take. So this is the plane. First I am taking a rectangular profile on it. That's it. Add it to 20 mm. Okay, run a small profile, so maybe 5 is sufficient. Okay, so in rectangular slab, now I am going to draw one vertical member. I can add it to 20 mm. Okay, so now bottom one is my base. You can change the profile color, etc. Now you can right click, you can go to property, you can change the color if you want, you can give the transparency, everything you can fix. Okay, so the bottom red color is the base and this is my vertical structure. So I want to create the stiffness support material for this vertical structure. So the stiffener will be in this vertical plane, right? So I am taking that vertical plane. It's a little bit inverted. It's okay. So here I can draw the stiffener. Okay. Stiffener can be a straight line, or even if you want, you can draw some curved stiffener also. It's up to you. So any profile you can define for the stiffener. Now you see the stiffener is enabled. Okay, select the stiffener, or it is asking the profile. So this is my stiffener profile and thickness is 1 mm. Okay, for example give 3 mm. You can see. So for this profile, this tool creates the stiffener between the vertical and the base. Okay, that's how we have to use the stiffener tool. The next one is solid combine. So solid combine is combining two different profiles, that is creating the solid profile from the two different 2D sketch. For example, this Y is a plane I am taking. Assume I am drawing one circle here. Okay, exit. Then now I am taking the opposite plane. Okay, Okay, there is a perpendicular plane to this circle. So in that plane I am drawing the rectangle. Now you see I have two profiles. Now I can use this solid profile. Okay, so this is my first component, this is my second component. Now if you preview, do you see it created the profile, that is created the solid between these two profiles. Okay, using these two profiles. So this cross section is circle, and this side the rectangle, it is taken as the length. Okay, even we will try some other structure also. For example, instead of this rectangle, I am taking only up to certain thickness, not throughout the diameter. Now you will see how it comes. Use the solid combine, select to profile. Now you can see. Okay, we created the material between these two profiles. Okay. Then the last tool is multi-section solid, removed multi-section solid. Again, this is to create the material, this is to remove the material. So multi-section solid means, so the pair tool I told you, if you have the circle, we can create a straight circular cross-section cylinder. Okay, and the rib tool means we can create circular cross-sectional cylinder which has the bend. Okay, that we can create. And this multi-section solid means we can create the cylinder with a different cross-section. That is, initially it has circle, then it has the cross-section of rectangle, then square, like that. In this single cylinder itself, we can have the different cross-section. So let's present that. Okay, initially I am taking one rectangular, one circular profile, 100. Assume the total length of the duct is maybe 1000 mm. Okay, so 1000 mm cylindrical rod. One side I have a circular cross section, another side I have a square cross section. So second square cross section I have to draw it after 1000 mm. So for that purpose I am going to offset the plane. Okay, which plane? The same plane where the circle is drawn. Same plane I have to offset. For that you can use this reference element. Okay, this plane tool you can use it. So now it is selected. So you see you can move it anywhere. Okay, and the length you can define it here. So I need the plane at 1000 mm. Okay, so this here it is created. So on this plane now I can draw the square profile. Take 100, and I can give symmetry. Okay, so now I have two profiles. One side circle, one side square. The total length is 1000 mm. So now we can use this multi-section solid. So we have to select first profile, then the second profile, then preview. It shows. So there is a small issue. So if you want, you can use the coupling mode to ratio. You can give that. See what happened. There is a twisting happened. That's why it shows the error. Okay, so as it says in the coupling you can give ratio. If you give, you can see the structure. Okay. Circle, this is rectangle, but again there is a twisting issue. I don't want this twist and turn. So how to avoid that means, you should see the closing point. So for this circle, here is the closing point. Then for this rectangle, if you see, it is in the opposite side. So how it will create? It will create the edges, closing edges from this closing point to that closing point. That is why it is twisted. So what I can do, this closing point I can shift it here so that both will be in the same side. So what I can do, I can right click this closing point, replace, then place it on this corner. Now preview, you see there is no twisting. Okay, there is no twisting. So we have successfully converted. So we have created the cylindrical rod. One side has circular cross section, another side has the square cross section. Okay, so normally it will say you can change the coupling to ratio. Ratio will be solved. Okay, but still sometimes there may be the twisting error. So what you have to check is the closing point. Closing point should be in the same side, same point. Okay, if it is in, for example, if the closing point is somewhere here, what will happen? It will lead to plus or some twisting will happen. So in that case, you have to check the closing point on both sides. You have to ensure the closing point is on the same side. Then you can create the thing properly. Okay, this is for the multi-section solid. Then multi-section, removed multi-section solid is same way. It will remove the material from this. Okay, let's try that also. First I am taking this plane and it's going to fit all in. Okay. So here also, if we want to create a duct that is tubular like structure, so for example I will try differently. So this side I need this circular profile. Okay, as in this side I need the circular profile. So I want to create the tube. So this side the cross section is circle. This side I want to create square. And use this normal view to change the direction of orientation, etc. Okay, now also I have two profiles. Now we want to remove the material between these two profiles. Use this remove multi-section solid. One side circle, another side square. Review, again the same issue is coming. So even if you change this coupling to ratio, it will remove, but there will be a twisting. Okay, so what we have to do, we have to check whether the closing point is on the same side or not. Okay, here it is on the right hand side top, there we will check it. Okay, so let's see that. So there is no twisting. Okay, so sometimes with the coupling ratio itself, issue will be resolved. Still, if it is not resolved, you should go for this closing point. Okay, so first option should be this coupling ratio. Most of the times software itself will show the notification showing the coupling to ratio. So if it is not solved, if it is twisted, then you have to check the closing point. Let's say. So next toolbar is dress up features. So sketch based feature is to create the solid model, then dress up features to do some operation on that created solid models. So you will see the tools. So before that I just created one square cube. You know how to create it. First one rectangle, one square profile. Then using pad, you can convert that square profile into square cube. Okay. So you will see the first tool. This is H fillet. If we expand further, you can see 5 types in that. So first one is normal H fillet. Using that, I can convert the sharp corner into the rounded one. Okay, just select the round corner, sharp corner. So here I can define the radius 20 mm. Now you can see it's become round corner. Then second one is, so first one is normal edge fillet, second one is variable radius fillet. The difference is, for example, I will select now this sharp corner. Okay, so 20 mm or 30 mm whatever you can define. And additionally here you can see these points, okay, two elements. There if you select, then you can pick n number of points on this sharp corner, and you can double click on the value. Instead of 30 I can give 20 here. This value also locally I can change it. Instead of 30 I can give 40. Like that, n number of points you can give in between. Now you preview, you will get this type of variable radius fillet. Okay, first one is constant radius fillet. First tool is constant radius. Second one is variable radius fillet. Then third one, there is also fillet, but instead of defining the radius, here we are defining the caudal length. For example, this side if you select, complete line it is taken. Okay, this line I am taking. This line I am taking. So caudal length. You can see instead of radius, it is taking this length. Okay, 40 mm. That I can change it to 50 or 60. So based on that caudal length, we are defining this corner. So first one is constant radius, second one is variable radius, third one is instead of radius, we are defining the caudal length. Then the next one, face fillet. To explain that, whether I can make another one model here. Select this face. Then I'm just drawing another one profile. Again pad it to maybe 50 mm. Okay. Now this face fillet, I am selecting these two faces and preview. You can see between these two faces there is a edge fillet. This also you can control 5, 20, etc. Okay, like that between the two faces it can be created. Then the last one is tri-tangent fillet. That is between the tri-tangent line or face. For example, okay, this is I am taking. So select the tri-tangent fillet. So faces to fillet. So these two faces. Okay, I have to create a fillet, and assume this face I have to remove it. Now if you preview, you can see. So these faces, there is a fillet edge, and this side it is completely removed. Okay, so I will repeat it. Now I have sharp corner in these two faces. I have to convert these two sharp corner into a rounded one, and also I have to remove this face. So in that case, you can go for the tri-tangent fillet. So these two faces, I have to do the fillet. I don't want the sharp corner, and I have to remove this face. Then preview, you can get edge fillet with removed face on this side. With this about the fillets. Next you will see the chamfer. Okay, so using chamfer we can create the instead of sharp corner, you can create the flat surface, flat corners. Delete it. Okay, so I am taking this as the base model. Assume I want to convert this sharp corner into a flat one. So you can select that chamfer. There you can choose which edges you want to change it. So default angle is 45. Simply you have to define the length of the face. For example, 10 mm I am giving. You can see the 10 mm distance. If we change to 20, like that. So this distance we can define. Okay, the default angle is 45 degree, and this distance also we can define. And also if you want, you can change it. Normally chamfer they will create it for 45 degree. So this is converting the sharp edge corner to the flatter one. Then the next one, draft, that is converting the straight wall to the inclined one. So first one is draft angle, then draft reflect line, then variable angle draft. Okay, so the same like, so first one is constant draft angle, the last one is variable draft angle. So we will see the first one. For example, this one is deleted, chamfer and deleting it. So select the draft angle. So angle is 5 degree. Which face you have to draft? I am selecting this face. I have to draft. And neutral element. About which element you have to draft that. So select that. I am taking this upper surface. With respect to this upper surface, I want to convert this vertical surface into the inclined one. So degree 5. If you want, you can change that to 20. Review. Now you can see this flat vertical one is converted to the inclined one. Like this, we can do the draft. The last one is variable draft. The same procedure. First you have to select faces to draft, then you have to select neutral element. Now you can see 2 points. Variable draft means select the point and you can create a number of points in between. And those intermediate points you can change the values. Now you see it is the variable draft. It is not the same angle 20, 30, 30, 20 like that. So the third tool is, the middle tool is draft reflect line. So that is we can draft this face with respect to this edge fillet. Okay, select that. So we select this edge fillet and preview. You can see this line is drafted, which is tangent to this edge fillet. Okay, so this is constant draft angle. This is variable draft angle. This is draft created with respect to this edge fillet. Then shell. Shell means converting solid body into a box-like structure. Let me show you shell. So I want to remove this face, okay, so that I can get the box-like structure. So if you want, you can select other faces as thickness. Otherwise, software will default consider other faces as the other thickness face. Okay, and thickness they are given 1 mm. If you want, you can change it. Now you can see the software removed this face and kept other faces with the thickness of 2 mm. Initially it was solid, now it is like a box-like structure. So it is a shell. The next one is thickness. For example, this face alone you want to increase the thickness. It is 1 mm. You can change it to 10 mm. So using this thickness, there alone locally you can increase the thickness. Then thread. Thread means actually here you can, if there is any cylindrical hole, that you can define what is the thread diameter, thread depth, etc. And what will happen? It won't be reflected here. Now we have seen the material is removed, a solid is converted into a box-like structures. Those things we can see. But this thread or tap option, so it will be only visible in this. You can see there is a thread with a diameter pitch. The details will be visible only in the tree. It won't be visible in this product. Only in the manufacturer you can check it. That is thread. Then last one is, so remove face. This is replace face. Almost the same only. So next one is remove face and replace face. So let me draw hole. So you can use this hole tool to make these circular holes. So I told you, market is to make the hole of any cross section. This hole tool is to create the hole of the circular cross section. So select the hole tool and select the flat surface. You can see that hole define what is a dia and what is a depth. Okay, and we can position it also because randomly it is created. We can position it using this positioning sketch option. So this white color point is the center point of the hole. For example, I can define the distance between this wall and the center point is 300, and this horizontal inches on this kind is 300. Okay, now it is in green color. We have positioned it properly. Now okay, there is a blind hole. Okay, so it is a blind hole. Here you can change it. Okay, so if you want, you can view up to last. That means material is completely removed up to the last. Assume I need a blind hole only. So give blind and the distances. PR 100 and PR. Okay, so one hole is created. Next one is remove face. So you can remove face. Assume I want to remove this internal face and I want to keep only this the outer surface. That means I don't want this whole itself. In that case, the pink color is the face to remove and this cyan color is the face to keep. You will give OK. See the pink color face is removed and it is replaced by the surface. This is one way. We are doing control Z. So second code also almost same. Instead of remove, it is doing replace the same way. For example, so the outer one is the my replacing surface, and I want to remove this pink color internal surface. Okay, and remove. Okay. So remove face and replace face. Same way. So next one is the transformation features. So if we expand the first one, you can see translation, rotation, symmetry, axis to axis. So to explain that, simply I have taken one small cylindrical 3D rod, cylinder, circular cylinder. Okay. So now I want to translate this object. So use the translation. So which to be 1000 mm I want to translate, about which direction it is asking. So I can translate this with respect to the any plane. For example, if you select this XY plane, you can see with respect to this plane 1000 mm it is translated. Okay, on both sides you can translate, or instead of XY plane you can select this ZX plane. In that case, along this plane, above or below, it can be translated. Okay, like that, depends on the direction of the plane, we can translate the object to the required distance. So this is the first tool, translation. Next one is rotation. So I want to rotate this about each axis. So in that tree also you can choose it. This compass about Z axis. Okay, see I want to rotate that with respect to the Z axis to the angle of 90 degree. You can see from here to here. Okay, so you can see if you rotate this compass also will be rotating. So this vertical axis is the Z axis, above the Z axis 90 degree it is rotated. And if you change some other plane, for example Y axis. So Y axis means above the Y axis 90 degree rotated, like that you can rotate it. Next one is symmetry. I want to make a symmetry of this object with reference to this plane. So opposite it will be changed. Okay. So in the transformation features, so this one we have seen translation, rotation, symmetry, and this one is mirror, and then this one is creating the pattern. It can be a rectangular or circular or any random user defined pattern. Then this one, if you explain, this will be scale and affinity. So first toolbar is over. The second one, the next one is mirror. The symmetry means this profile will be shifted to the opposite side, the same distance. Mirror means both original profile, modified profile, both will be there. Okay. So this object I have to mirror it as per this plane. Okay. So both original and duplicate model, both will be there in the mirror. But in this symmetry, original itself will be moved from here to here. Okay, so this is mirror and creating the pattern. So first you will see this rectangular pattern. So I want to create rectangular pattern using this profile. So create rectangular pattern. So how many instances I need? I may need 5 instances. Okay, and with respect to this horizontal plane, I have to create it. You can see now itself 5 is created, and spacing between those will be, for example, 500 mm. Okay, so this is the object I have to create as a pattern, rectangle pattern. So I have to create 5 objects. Each should be spaced between spacing between these each component should be 500 mm. Along this plane I am creating it. Okay. And this is for the first direction. Similarly here you can see the second direction. There also you can define. For example, here also I have to create 5 instances and 500 mm gap between those. Okay. The direction you can change it here or there. You can change it. With that we can create a pattern of the same object. Okay. Equally spaced objects you can see. This is the rectangular pattern. The same way we can create it as a circular pattern. For example, this object is a circular pattern. How many instances? For example, 6 instances. Angle between those products should be 60, and the reference element is this plane. The plane which is parallel to that. Now you can see a circle of 6 instances. For each 60-degree gap along this plane is created. Here also you can create curve. Okay, only one layer I have created. Okay. If you want, you can create how many circles you want. For example, 3 circles. Each should have 100 mm distance. Okay. The direction you can change it. Here or here. Circular pattern. The next one is user defined. Actually, in this rectangular and the circular pattern, we get the option. What is the angle? Okay. What is inside, outside? What is the spacing between those things? And all we got it. This is the user can define any type of pattern, not only rectangular or circle. For example, go back. Only one cylinder. Now go to the sketch. Okay, I am creating some series of points. Okay, assume these points are properly constrained. Okay, I have given proper dimensions. Like we assume. Now we will see these are all the points I have created. On that I have to create this same profile. So now first select the object you want to pattern. Now you can select the points or positions. You can see on these positions the same object is created. Okay. So first one is predefined. It should be rectangle or circle. Last one is user defined. User can define any pattern, any shape. Okay. So next tool is scale. Okay, expand. You can see two tools. One is scaling, another one is affinity. So scaling means we can do the scaling in only one direction, along only one plane. Affinity means we can do the scaling in all three planes in directions. Okay, so this is the object I have to scale. Select the scaling tool. It is asking the reference. For example, I am selecting this plane as the reference, and 10 times I have to increase the ratio. Now you can see that the modified profile. Okay, this is 1 times the length. Now the length is increased to 10 times. Okay, so instead, if you select some other plane, for example, this y is a plane, see along this side, the 10 times it is increased. So only along one direction you can change the scale if you use the scaling tool. So the next tool is affinity. So scaling will do increasing scale in only one direction or one plane. Okay, but this affinity will do scaling in all three directions. Same, this is the object I have to scale. So select the object, then go to the affinity. It is asking the origin point. Actually, we don't have any origin point, so you can create it. Simply right click. It is telling create the point. Okay, it is taking already one surface. Okay, but I will choose which surface, YZ or any XY plane or any plane you can create. YZ plane, ZX plane. Okay, any plane you can create. You can take it. Assume I want to create the point at the center. Okay, so I enter 0. Okay, now see the certain point is created. Now you can do the scaling by giving the value in this XY set. So I am giving X is 10 times the ratio. You can see along the X axis. You can see this is the X direction, Y direction is Z direction. Okay, along X direction 10 times it is increased. Now along Y direction, that is also 10 times it is increased. Then along Z direction also 10 times. So completely the whole object is increased on all three directions. This is how you have to use the affinity. So scaling will do scaling in only one direction. Affinity can do the scaling in all three directions. The center point alone you have to create it. Okay, we will repeat it. First select the object, then affinity. You have to create the origin point. Create the point. By default, it is taking one face. That is this outer face it is taking. You can change it to any plane or anywhere you can create it. As I am creating on this ZX plane, I need this to be in the center. So define 0 here. So the point is in the center. You can simply define the values for X, Y, Z directions. That's it. 10 times it is increased. Then our last one, reference element. So you can create point or line wherever you want. You don't need to go to the sketcher. Here itself you can create it. So along this face you can see I can create a point. Okay, you can define the distance, etc. Similarly, you can create a line. Okay, so between these 2 points it will create a start point, maybe for 100 mm. And to this it is created. Okay, need 2 points. It can be a point or a plane. Between it can be created. You need to go to the sketch, or you can create planes. For example, you want to create another plane. So assume this plane I have to offset. So use this plane tool. You can see it is moving on both directions. Yeah, that's it. So sketch based features, reserve features, transformation features, reference element, mainly the sketch you selecting that, you can go to the sketcher module. There you can draw the 2D profile, then exit to the part design again, you can convert that into 3D. So next one is wireframe and surface design. So in that module, that is mechanical design, you have to go to wireframe and surface design. So in that, 3 important toolbars are there. First one is surfaces. So where we can convert line sketch into the sheet model. Then operations, where we can do trim, all other operations, mirror, scale, etc. The last one is wireframe. Okay, this included the reference also, that is how to create reference point, line, planes, etc. So to explain the tool, just I create our own profile. Okay, just using this spline tool, create our own line and profile. Now let's see the first tool in the first toolbox, surfaces. So that is extrude. So in the part design, so we have studied, we have discussed the pad. Same way here it is extrude. So this extrude will convert this line into a sheet. Okay, so you can define the thickness, other things in this table. Okay, so both side length you can define it here. So first one is extrude, which converts line into a sheet. Then second one, revolve. I think in the part design we have studied as shaft. Okay, to create the axis symmetric model. Same way. So select this revolve tool. So I have to revolve this line around the axis. So I want to rotate about this vertical axis. You can see this type of sheet metal structure you can create it using that if you revolve. Okay, so here you can control the angle 0 to 180 degree or completely 360 degree, anything you want, you can adjust it on that side. So second one is revolve. Then third one is creating the sphere. So simply you have to select some center point. Then you can control what is the radius, all other start angle, end angle, etc. Okay. So what is the start angle, end angle, all those things you can control. Okay, either in this model itself or in this table you can control. Okay, and here itself there is 2 options, sphere limitations. First one is will create only the certain portion of the sphere. Second one, if you select, it will create a complete sphere where you can control only the radius. Okay, then fourth tool is creating the cylinder. Here also simply we need the center point and the axis on which we have to create it. And selecting this angle, you see the cylinder is created. You can adjust the radius and both side limits, etc. So all other things you can control in this table. Then the next one is offset. Offset, same way we can increase or decrease the scale for a particular distance. For example, I have one surface. Okay. Then using this offset tool, I can offset it to a certain distance. So 15 is too much, so shows error. If you see 20, you can offset it. Okay, there will be a limit. Simply we can extend this to infinity. There will be a limit up to which we can offset. Okay, like that it can be decreased or increased. We can offset the profile. So next tool is this feed. So first, so we need one cross-sectional profile and one guideline similar to the rib section. So guideline is here. So let me create one cross-sectional profile. Further, I need some plane. The profile should be drawn from the center point, or if it is somewhere other than the center point, we can offset the plane to this point. So I have to choose perpendicular plane. So this plane is perpendicular XY plane. Using this reference element plane tool, I can offset this to this point. So I have the plane now. There I can draw the cross-sectional profile. Assume I am taking a circle on one side. Okay, one side I have a circle. now I have cross-sectional profile and the guideline. Now you can check this sweep. Okay, so cross-sectional profile and this guideline you can preview. So you can create a tube with a bend similar to a rib. Then next one is fill tool. For example, by selecting this, I can close this gap. Not only this, for example, you have 3 or 4 lines which are closed profiles, and by using that, we can create the surface between the closed profiles. That is the fill tool. And the next one is multi-section surface. So this is similar to the multi-section solid. Multi-section solid. So we can create the tube of different cross section. One side circle, another side rectangles. Here also we can do the same. Let's try that. Assume one side I have the circle, another side I have to create the square or rectangle. So again I need one plane to create the sketch. Take this reference plane tool, then I can offset this plane to this point. Now I can create a profile. So profile is created. So I have 2 profile. Now let's create this. Let's use this multi-section surface. So these 2 profiles I am selecting initially. View preview. Okay, you know how to compare the closing point. It should be on the same side. Here it is on the right hand side. So this point I can replace it to this corner. Now preview. Now it is created without any twist. So this is normal multi-section surface. And if you want, you can use the guidelines as spline also. For example, I can take this as the spline. Now if you preview, the tube will be bent along that guideline. One side it is rectangle, one side it is circle. Like that you can use this multi-section. Then the last tool is blend. So blend means, so it will create the appropriate joint curve, joint surface for the 2 surfaces. Okay, any 2 surfaces you can select. Then the software will create appropriate curve with joints both the surface. For example, I will take these 2 profiles. So first let me create the surface. So using fill option, I can fill in this circle. So I can convert circle into a circle plate. Similarly, this rectangle also I can create rectangular sheet. So 2 sheets are I have. Now if you select this blend tool and select these 2 surfaces, you see it is creating appropriate joint surface. Okay. Secondly, to explain the same blend tool, I have taken randomly just 2 rectangular sheets. Okay, it is not aligned properly. Randomly I have taken 2 sheets. Now let's see how that blend works. Select this blend tool. So this is my first curve. Then this is my second curve. Now let's see. Software created the sheet which is appropriate between these 2 rectangular sheets. Right? Like this the blend works. So next toolbar is operation toolbar. So the surfaces is to create sheets from the 2D sketches. Then the operation toolbar is to do the operation like join, split, project, translate, rotate, scale up, extrapolate. Those kind of operations we can do it in these operations. So let me first explain this split, then you can go for this joint. So if you take the split, there is 2 tools. So first one is split, second one is trim. So first let's explain this split tool. So for that I need 2 sheets. So let's create that. So select any plane. Is it explicit? Explain. So I'm going to draw one rectangle. So we know how to convert this rectangle into a sheet. Simply you have to use this fill tool. So this got created. Now I need another sheet which is intersecting with this. I can do the same procedure, drawing the rectangle and fill it. But instead I will go for this extrude tool. Both will do same only. So I'm selecting the same parallel plan. On the plane I'm drawing one straight line somewhere here. Now I can convert this line into a sheet using this extrude. You can see both sides it is extended. Okay. So mirror extend means here still you can give dimensions. If you don't give mirror extend, both sides you have to define. Okay, so okay. So now I have created two sheets. Now let's see how the split and trim works. So select the split tool. So using that split, we can convert a single sheet into the two pieces. For example, this is a single rectangular sheet we have created. Okay, so this is the element to cut. Okay, I have to convert the single sheet into two pieces. Then cutting element, using which I am going to cut it. So I am going to use this line, intersecting line. Using that I am going to cut it. Now you see, it is split into two halves, and it is keeping only one side. This side will be removed. That's why it is in transparent color. But if you want to keep the another side also, then you have to use this. Keep both sides. Now both sides will be kept, and it will be separate parts. You can see. Now you select this select as a separate sheet. This select as a separate sheet. So this is how the split works. So if there is no split, sometimes if you mistakenly select on this line of the tree, it will become in dull color. Most of the tools will not work. Okay, don't panic if it happens. Simply you have to select on this line of the tree. Okay, it will come back to its active mode. Okay, I delete this split option. Now if you select without split, you can see this select as a single sheet. So split we explained. Now you will see the trim. So it is asking trimmed element. So I am selecting these two elements as a trimmed element. Now you can see it is keeping only these two sides. These two are in the transparent color, so that will be removed. But you can change it. You see now this side is removed. Now that side can be removed like that. You can choose which side you want to keep, which side you want to remove it. Okay, so this is how the trim works. Okay. Then we will see the join tool. That is easy only. For example, if I split this sheet into two, okay, using this line I am splitting this. Now it becomes a two sheets. Okay, if you select separately, it will be selected. If you want to join these two sheets, you can select this join tool. So select this one and this one. Now okay. Now if you select, it will be selected as a single sheet. You can see orange color on both sheets. Okay, both are selected as a join tool. Then project tool. That also if we expand, you can see two projections. For example, any edge if you want to project similar to the 3D element, project 3D element, it works. For example, select this corner. You can see now there is a line. Previously there is no line. So we will do the control Z. Now there is no project. Okay. If you use this project tool, I can project the line on these edges. You can see the edges are projected. This is for 2D normal projection for the boundary, and this is for the extract. For example, this complete sheet itself I can project it. So using the first tool, I have projected only the edges. Using the second tool, the complete face I can project it. For example, you can see here, this complete sheet got selected and I have projected. For what will happen, this project tool, whether it is a solid surface or a sheet metal surface, it will convert that as the sheet metal. So already there is a sheet metal. Even though if you extract from the sheet on it, it merges one over another, so it is not visible. So if you want to clearly visible how this extract tool works, you can go for the solid model. For example, I'm creating a rectangular slab, a solid rectangular model. So for that you have to go to the mechanical design, part design. You can use the pad tool. You can give 500. Okay, now we have the solid 3D design. Now go to the wireframe surface design. Now if I select this extract tool, for example, this face I have to extract. Now give OK. You see, we have extracted one surface from that face. But in previous case, original also sheet metal, what we extracted also sheet metal, so both are at the same color, we could visualize properly. But here it is solid, it is sheet, so we could visualize easily. So this is how extract will work. Then this toolbar, this is very common. So you can do the translate, rotate, symmetry, scaling, affinity from axis to axis. Almost similar operations like we did in the art design. So okay, you can see that. So for that again I need one sheet metal. For example, I am creating a rectangle here, but I can convert as a sheet. Okay. So now we know how translate will work. So I can translate this sheet to the desired direction, which direction we need. You can select from this plane, or you can select from this tree, or here also you can right click and select. For example, this plane I am selecting. Okay. Then for this plane, on both sides I can translate this. From here or there I can translate, and you can give the appropriate values here. For example, 3000. This side is translated. If you want, you can change the direction, another side, 5000. So this is how translate will work. Then rotate. So I can rotate this sheet with respect to the axis. So this sheet I have to rotate with respect to this axis. Here I can select, and here also right click and select. It's up to you. So with respect to this I can rotate this. So that angle you can define here. 60 degree, 90 degree, those things and all. So this is how rotate works. Then symmetry, you know that. So it's the same image I can create it on the other side. So this is the image I have to do the symmetry about this plane. So you can create the image in the opposite side. Okay, this is the symmetry. Then scaling also, you know that I can do the scaling for this sheet. The ratio maybe 5 times I'm giving, and reference it is asking which plane. For example, this plane if you select and preview, it is not visible. So let's see the another plane. You can see. So for this plane on both sides it is changed. Okay, we can change the ratio also, 5 times, 10 times, how many times you want. Similarly this side if you select, you can see here it is. Now the scaling is done. Like that, depends upon the direction or plane, we can do the scaling of that model. Affinity also, you know that. So all 3 directions we can do the scaling. Only one thing is the origin point you have to define. Okay, so here you can easily select it, so not an issue. And you can give 5 times in this direction, y direction, z direction, any direction, you can do the scaling. Okay, then axis to axis. Instead of translate, if 2 axis systems are there, so simply you can select this model. I have to translate from this axis to another axis, like that it can be done. So then the next toolbar is wireframe. In that first 3 is familiar to you. So we can create the points, lines or planes for the reference. Already in the wing design, we have shown how to create the planes, etc. Then these 2 things are just creating the projection. Okay, again we can project the edges. We can project the edges between the intersection point. If 2 sheets are intersecting, then the intersecting line I can project it. Okay, so further it is using. Then this is also to draw the any lines or tangent corners or connect curves, etc. Okay, these are all just for the reference. Okay, you can project, you can draw the lines, splines, points, planes, everything for the reference. For example, if you have 2 points, one is at 0, 0 point, another one is at 50 mm, 500 mm. So it is small, 5,000. So here is a point. So I created 2 point. Now using this spline tool, I can join these 2 points. Okay, if it is straight, if there is another one point, then it will curve. It will create another one point also. In this plane, somewhere here. So now I have 3 points. Let's see. I am selecting these 3 points. So I can create the spline between 3 points. We can use that as the reference, or even you can convert that into a sheet. For that purpose, we are using this spline, circle, those things and all. And the last one is the interesting tool. We can create the helix. Okay, so where you can use this helix means to create the thread-like structure. It will work on both sheet and part design. Okay, so this helix, we can create the thread-like structure in both sheet and solid. Mostly in the solid only we use it. So let's show that. Okay, so for that I am creating just one cylindrical rod. So you can rotate. As I said, we can do it in both sheet and part design, but if you do it in part design, it will be very easy to visualize. So I am going for the part design. Move this axis rotate. So to use the helix, you have to go to the wireframe surface design, select this tool. So what it is asking you on starting point and axis. Okay, so starting point, for example, on this corner I am creating the starting point. So point is created, and which axis? From the tree, I think I have seen that as the Z axis. On this axis I am creating. We can define what is the pitch, maybe 20 mm. What is the height? Maybe 100 mm. Let's see how it comes. You can see the helix. And on the outer side, you can towards the direction. So 100 is very small. You can give 500 or even 3000. Okay, so 3000, which I am giving as 500. You can see. So pitch distance is 500. Total length is 300. Like that, I can create the helix. 5000. So like this, I can create the helix. So if you want, you can now it is straight. If you want, you can do the tapering also. You can see inside it is reduced, because for the screws and all, it will be tapered. Normal nut and bolt there, if you see, so it will be straight, but in the screws it will be inclined. So they are giving this option, tapered option. So let's create a normal thread-like structure. So helix is generated. Okay. From the helix structure, if you see, something it will be like a rectangular shape, something it will be like a cylinder, round shape. So any cross section you can take. For example, I am going to draw the circular cross section thread. So again, I need the circular cross sectional profile. So for that, the profile should be drawn in this starting point or the end point. Then you know which tool you have to use it. Okay. So if you know the circular cross sectional profile and guidelines, then we can use the trim, that is so this zip tool. Okay, so you can use this zip tool to create this solid thread-like structure, or if you want to create it in the sheet metal, surface design, you should use this sweep. Okay, So where you need the cross-section profile and the guidelines. So let's draw that circular profile. For that I need a plane on this point. So let's create a plane. So which plane, any plane, choose it and select the target point. So the plane is created. Okay, the plane is perpendicular to the profile. Now we can draw the circular profile on that plane. So any profile you can draw on it. Okay, now better I will show both sheet and solid model. So in the sheet, if you want to create, you have to use this sheet. So we have to select which profile, this circular profile. There is a guide curve. This is my guide curve. Now preview. You can see the spiral sheet-like structure is created. Okay. So instead of the sheet, you can create the solid structure also. So here we use the sweep. So in the path design means you have to use the zip tool. Okay. So this is my profile. This is my center curve. You see the solid field structure is created. So for that we are using the helix tool. And that's it. We have covered almost all the tools, important toolbars. So surfaces, operation, wireframe mainly for the references, and finally sketch to create the tool. So that's it about this wireframe and surface design.